Good morning. My name is Markel. I will be demoing the 1-point proctor, part of your soils certification compaction course. There are tools we're going to need to perform this test. They are pie pan, small brush, spoon, 4-inch mold with collar, calculator, straight edge with a beveled edge, and this is the top of the mold. Also, number 4 sieve. The first thing we want to do is we want to weigh the mold without the collar. I need to make sure everyone has this form, 1-point proctor form. This is the form that we use for your practical testing. And on that form, again, our first step is going to be weigh the mold without the collar. And as you can see, based upon your paperwork, number 2 line also states we will weigh the mold in pounds. This is your pound scale. This is your gram scale. So when I weigh my mold in pounds, it comes up to 9.55 pounds. You want to write that in line number 2. And the reason why it's 9.55, because when we weigh our mold, we weigh it in hundredths, which is 2 places behind the decimal point. Again, 9.55 pounds. The next thing we want to do, we want to attach our collar to our 4-inch mold. You want to make sure it's snug so it doesn't move the top or the bottom. Now, before we get to the field, the 4-inch sieve is important because we have several test methods. If you refer to page 122 in your manual, you will see that there are 4 test methods. Method A, B, C, and D. We will be doing test method A, which is for fines, 4-inch mold, as I've demonstrated. Number 4 sieve, as I hold up. 25 blows, 5 layers, 10-inch hammer with an 18-inch drop. Again, this is very important. Noteworthy, as it said. Please know where this page is. You will need it during your practical test. Again, it's page 1-22. It is in your manual. We'll now take our mold to our field. This is considered our field. Pre-prepped soil boxes. During your testing, your soils will be prepared for you, so there's no reason to worry about using the number 4 sieve. The number 4 sieve is to be used in the field, not in classroom settings, which in turn, this is what you will be exposed to, this is what you will be tested upon. Just to recap briefly, 4-inch mold, 5 equal layers, 25 blow per layer, rammer, 10-pound rammer, 18-inch drop, free fall. Meaning, I bring my rammer up, I release it. As I begin to show the demonstration, I will further explain that particular item. Now, what you want to do, once again, is make sure your mold, the bottom of your mold, is locked in place. Take the top of your mold, put it in place. Screw your wing nuts down, placing it securely. Test it quickly to make sure it doesn't self-release. You want to mix up your soils, get them going a little bit. Again, you will not have to sieve. These soils in class is prepared for you. You want to get about 3/4 of a scoop to create your first layer. Placing the first layer in the mold. Spraying it around with your hands evenly as possible. Very important. You want to angle your 4-inch mold in a diamond setting, meaning the point should be in front and it should be a point back to your ankle, placing right or left foot, depending on your hand placement. You want to put your foot on the corner of the mold. I've elected to use my left foot. Some may like to use the right foot. Doesn't matter. It's important that you demonstrate this particular art when you're doing your practical testing. Place your rammer inside of your mold. 25 blows. Making sure you keep your rammer straight as possible. It's a little tough for us taller guys, so I bend a little bit so I can look down inside. Upon you performing or using your rammer, you want to make sure you go outside of the mold. The reason being, because of the diameter of the rammer, it covers the center of the mold. So there's no reason to strike the soils in the center of the mold. The rammer takes care of that for you. You want to be consistent. Again, keeping it straight as possible. Watch your hand placement. I like to keep my hand placement below the circles, because if you keep your hand up here and this rammer comes down, it's going to be very painful and you're going to have a rough day. So, hand placement here, on my back, leg, keeping it straight. Lift the rammer up, as you see, and I will drop it, free fall. Stopped at 15 for a reason, to check my mold, to make sure for this. This is what we call a plug. You have two options. You can take the plug, break it up, put it back in the mold, or you can simply discard it, put it back to your soils in the ground. That typically happens when your soils are a little moist, opposed to them being dry. First layer. Layer 2, 25 blows per layer. Is that 15 again? Layer 3. Again, check. So again, to me, this indicates my soils are moist, which is not a bad thing. It's just going to give you optimum compaction. Fourth layer, and this is when it gets critical, because your fourth layer should be an eighth, almost a quarter of an inch lower than the top of your collar. The reason being, when you put your fifth layer in, it needs to accomplish your fourth layer and your fifth layer. And when it comes to your fifth layer, you want to have about a quarter over, maybe an eighth, and I'll show you why. Again, making sure it's even as possible with a little handwork, moving it around. If you come in, you can see that it's right at the top of the mold, but once I compact it, it's going to compact down, so it'll be below the top of your mold. That's what you want, and again, I'll show you in the next two steps. Fourth layer, 25 blows. Looking for plus. I choose 15. You can choose any number you want. However, keep a conscientious count of your number of blows. Free fall, lifting up, releasing. Now, that's it. Handwork. That should be good. That should be what I'm looking for. Nothing. At this point, compaction is completed. 5 equal layers, 25 blows per layer, 4-inch mold. Now, we have to take the mold back to our lab to weigh the mold with the wet soils. As you can see, there's soils on the bottom of your mold. This is why we recommend you have a small brush. It's not recommended that you tap it. A little shake won't hurt, but please don't tap it. As a proctor, that's what I look for, is to see if you tap this mold. You don't want to do that because the molds are calibrated and the molds won't chip, but it is metal and it will dent. The mold is clean all the way around. The mold is clean as on top. Now we'll prepare a compact sample for the lab for weighing of the wet soils. Another noteworthy process is when removing the top collar. We don't want to see you yank this off. Take your time, loosen your wing nuts, slowly twist. Left and right, left and right, left and right. Lift your collar, straight up. This is perfect. As you can see, that's why it's important for the fifth layer to rise above the top of the mold. As you can see, what I was looking for, quarter, eighth, somewhere around there, not much more. This is where your beveled straight edge comes in. Now, we're going to prepare once again to weigh our wet soils and our mold. Flat edge, beveled edge. You want to take that, you want to get that in the middle, and you want to saw it back and forth. Repeat the process, and you want to be gentle because you don't want to create any unnecessary voids. If by some chance you create a small void, it's okay to pick up some new soils, replace that void. If by some chance you have a huge hole, it is recommended that you do the test over, because at that point, we will consider it invalid. And as you can see, I've been doing this for a while, so I kind of eyeballed it, you know exactly where I need to go to make it flush. And there it is, it's flush. Again, cleaning your mold, not tapping it. I have a practice of slightly shaking it first, just a little wiggle. Coming back with my brush. Now, will this extra soil actually make a weight difference? No. It's truly about aesthetics and making sure that you have the best compaction sample you can gather. As you can see, it's now ready for weighing as well as sampling. I often touch it just slightly, just to make sure it's perfectly flat on top, which in turn it is. Grab my mold with 2 hands. I make my way back to my lab. Always, make sure you zero tear your scales out. You don't want your numbers to be off. You find a lot of times some of the students come in, they forget to zero their scales, throw their numbers off, they don't know why. Noteworthy, very, very important. Any measurements, always zero your scale. This leads us to line 1 on your 1-point proctor worksheet, which states weight of mold plus weight of wet soil after tampering. Again, in pounds, as demonstrated. Wet soils, that's your 5 layers. It's now tampered. 25 blows per layer. 10-pound rammer, 18-inch drop. I'm weighing my mold. It weighs 14.25 pounds. Again, we're weighing in pounds. Your worksheet will dictate at the end of the sentence. Weight of wet soil in mold, line 3, as it states, line 1, which is a 14.25, minus line 2, which is your 9.55, which was the weight of the empty mold without the collar. Please, please, please remember that. You see it moreover, the students weigh the mold with the collars, numbers off the charts. Can't figure it out. 14.25 minus 9.5 equal 4.7. Zero. Again, because it's in hundreds. So it has to have that zero as a placeholder. Number 4 line, wet density of soil and mold. Line 3, which is your 4.70 we just gathered, times 30. Some would ask, why times 30? Because it takes 30 for its mold to generate 1 cubic foot. That's why you see the cubic foot at the end of that statement. So let's do so. 4.70 times 30 equals 141.0. That measurement is measured in tenths. 1 space, the 0 again is just a placeholder. Number 5 and 6, we have to wait on that because then we have to go to the moisture part of your worksheet. It's going to be here in order for us to get 5 and 6. So the first thing you want to do, remove your compacted soils, and you want to weigh your tear. I like to tell the students, you can mark out the word tear if you choose. You simply use pie pan. This is your measuring unit. It's easier, you won't forget it. So although we have lines 1 through 6, we're actually going to start with line 3. That's going to be your first step. And also we ask the students to put a 1 first step. That way they can better manage, they don't get confused. You weigh your tear, again, making sure it's zeroed out, which is going to be tear on your gram scale. Again, as instructors, we ask that you do not change the method of weight. The scales are preset. All you have to do is just get your values. Pounds indicated on the pound scale by LB. Grams indicated on the gram scale by G. Looks closer to a 9, but it's actually a G. As I weigh my tear, I get 188.5. All these measurements will be in the tens. That's why it's 188.5. Okay. Second step. Grab my tear, my compacted soils, back in the field. And as stated by my team member earlier, it's a minimum of 500 grams for your sample. Please write that down. And she stated strongly, it is noteworthy if you do not obtain 500 grams as a minimum, your numbers are going to be off, and then you're going to have some problems. You want to remove the bottom of your mold. Set your other mold aside. The base, I guess I want to call it. As you can see, this is the top collar. What you want to do, for some, put it down, then they turn it over. For some that may be confused, just put it back together. Flip it over ever so gently. Lay it down. And this is how we're going to get your sample to do your moisture burn off. And then, in this case, you can use the rammer, and we do allow you to be forceful. That being said, like so. Again, watching my hand placement, I don't have to step on the corner because I'm not compacting. I simply want to remove the material. Force it down. However, moving it in a circle, making sure not to hit outside of the mold. If it does, or if you do, you're going to look at you really strange because it generates a very loud sound, so we know. You don't have to be there to know that you hit the outside of the mold. Set your rammer aside. Again, as shown earlier, ever so gently, twist right to left, and lifting straight up, not a tear, straight up. You can see it's loose, lifting straight up. This is pretty good. It's not going to happen in, oh, it's really good. This generally doesn't happen in the field, doesn't happen here often. However, as you can see, my sample came out. It's a pretty good cylinder. I want to set that aside. I want to repeat the process because I need to get all of my compacted soils out to get my sample from my moisture. Repeating the process. Down, circular type motion. Take your time on it. Try to get as best you can. Eventually, it all comes out. Again, twisting slow, not ripping, lifting straight up. As you can see, this is what I have. I have two options. Try and flip it over and get it out, or I can simply lift it up and see what happens. Nothing happens. Therefore, you can use your thumbs to get that sample out. And as you can see, since my soils are moist, it's not very hard. This is really good. It's really, really good. Okay. Set my mold aside. And this is critical. How you're going to gather your sample. Cut the sample in quarters. Beveled edge, straight edge. Try to get it centered as much as possible. It's going to fall apart. It's okay. I'm going to show you why. And the reason why we're cutting in quarters, it's going to fall apart. Don't worry. We cut it in quarters because we really want you to get the sample from the inside. Because as you can see, it's really even, which means it was good compaction. That's going to encompass all 5 layers. It's not a perfect science. Just make sure you have 500 grams from those areas. My hands are a little bigger, so I can add a little more. As my teammate demonstrated, the weight, minimum 500 grams. Again, this is the middle, so I can grab some there. That should be 700 grams. Okay, back to the lab. Again, making sure my scales tear it out. Tear it. Zeros. Wet. Wet soils, which is going to be line 1 of the moisture section, which states where the wet soil plus my tear, where the wet soil plus my pop pan, 800, 9 grams. I'm sorry. Yeah, 100.9. Glasses get a little foggy. So, then we want to prepare line 3, which is, now what we want to do is, we want to remove some of the soils for our moisture burn off. As my teammate stated, there are no hot plates, no Bunsen burners, no hot eyes, none of that kind of stuff allowed in the building, so we don't use fire per se or external heat. We are to remove some by hand. Again, you big hand fellows such as myself, you're going to be careful, but you're going to take out some. That represents your moisture burn off. Moisture burn off means that you dried it out. So when you do a moisture burn off, you're taking out all the moisture in your soils. It's simple terms. You're in class, but if you were in the lab, you just put it to the side. Okay, so once that happens, my soil has now been reduced to 706.6. That's line 2. Now, we're down to line 4. And as it says, we're in the dry soil, which is line 2, 706. So 6.6 minus 188.5 equal 518.1. Okay? Now we're going to line 5, which states weight of moisture. Line 1, which is going to be 800.9 minus line 2, which is going to be 706.6, equaling 94.3. And the last step, which is going to be percent of moisture. Mess that up. As my teammate stated, all mathematical works, parentheses first. If you look at line 6, you see line 5, which is 94.3, divided by line 4, which is 5.8.1, equaling 0.1820111. Multiply that times 100. I can see it. I've done it. 18.2. 18.2. Now, that's the moisture percentage. I know when you look at your calculator, you're going to see 18.20. Remember, these measurements are in tenths, so you eliminate 0, leaving you 18.2. And line 4, we have 141.0. Now these numbers are significant because line 4 from the top of your worksheet and line 6 from the bottom of your worksheet is where we plot on the family of curves. Don't let this form intimidate you. A lot of people are very afraid of it. But I'm going to show you how you can accomplish this goal. Again, taking 141.0, I put that to the left of my family of curves sheet, like so. .0. This designates my wet density volume. Line 6 from your moisture goes at the bottom. 18.2%, as you can see, moisture content. Now, with those two numbers, this is why we call it plotting on a family of curves. I have to find that 141 on a family of curves, and I have to find that 18.2 and see where they meet. Also mentioned, this is when it's good to have a straight edge, meaning a ruler. You can even use your straight edge if need be. So let me find the 141 I have here and the 18.2. Okay, hopefully enough. We compacted these particular soils, and our values kind of end up right there, as you can see. That's my 141 coming up. It's my 18.2 for my moisture, coming from bottom to top. They meet right there. Right here, this dot means this. Yeah. So with that dot right there, you want to follow the curve. As you can see, it kind of goes around. So you can hit the dry density bar. This is called your dry density bar. All right, dry density bar. These are the proctors that have been run to create this family of curves. So from here to here, very easy. Just follow that curve. It's not an exact science. It all depends on what size your dot is going to be. I'm a little heavy-handed, so my dot is a little bigger. And as you can see, I hit my dry density bar. From that dry density bar, not from the dot, not from your initial dot, from the dry density bar dot. Come straight down to get my moisture, which is going to be like roughly 18.9. Okay, then from dry density bar, we go diagonal, not crossing any lines. That's going to give me 119.3. I'm going to show you why. As you can see, if you can see, it's a little difficult, but we're going to work it out. Once I got to my dry density bar, my moisture and my wet density meet at this particular point. Once I get my point on my dry density bar, I came down, which gave me my 18.9. Then diagonally, from the dry density bar, coming down to my dry density, 19.1, 19.3, as you can see. If by some chance your dry density number ends up over 141, you know it's incorrect. Because remember, this is your wet density value, this is your dry density value. So if you're taking water out of your soils, it should be lower because you're drying it. Your moisture is just what it is. It's a mathematical calculation. Now, with those two numbers, after we've plotted on the family of curves, we took the family of curves, we took those values, we ran into our dry density bar from our dry density bar, diagonal, straight, we have a value for line 5 and line 6 now. So line 5 is going to be 1, or 9.3, and line 6 is going to be 8.9. These two values will be the two values that you would test that particular soil by. We have another discipline as explained in the beginning for my teammate. This number and this number is what you would use to put in a nuclear density gauge. One last note. If you run your compactions, your 1-point proctor test, and your value comes outside of the family of curves, it's a trick just for you, because that way we can tell if you know how to plot one of the family of curves. So let's just say in the test I ran, if my point came here, that tells me what? Those soils do not match the family of curves. So it's a different soil, so it's going to have a different value. With that being stated, we will provide values that we know fall within the family of curves. Again, I am Markel, SHA Field Team, Soils and Aggregates. Thank you for your time and patience. Good luck.